Good morning, boys and girls. It's Mrs. Ryan. Today we are going to be talking about relationship tables, paired numbers. So relationship table, you've also heard them called input-output tables. And so they are also called paired numbered tables or function tables. They go by a lot of different words. So when we start out looking at our relationship tables, we're trying to find the relationship between the numbers that are in the table. And relationship tables always follow a rule or a pattern. So we always have to find the rule or the pattern of the table first. So most tables, we're looking at the numbered operation. What's happening? If I put in a 5 and I get a 7 out, what math operation could we be doing? So I'm looking first at this first one, 5 and 7. And so if I think about that, I know that I could do 5 plus 2 equals 7. That works for me. But for it to be the rule or the pattern of the entire table, it has to work for every set of paired numbers. So if I look at the input, my next set of paired numbers is 10 and 12. Well, if I add 2 to 10, does that equal 12? Yes, it does. Good job. It does equal 12. So I'm going to put a little check mark right there. And then let's look at the next one in our table. It says 1 and 3. So if I have 1 and I add, and I'm just going to show this like this, if I add 2, do I get an output of 3? 1 plus 2 is 3. Yes, that works. And then let's look at 6. If it's my rule, and it looks like it is because it's worked so far, if I'm using the rule of plus 2, then 6 plus 2, does that equal 8? Yes, 6 plus 2 more equals 8. So what then, boys and girls, is our rule for this table? It is plus 2. The rule is we are adding 2 to every number we input into our table. Okay, boys and girls, we're going to do another example here. And so I want you to remember, for it to be the rule or the pattern of the table, it must work for every number you put into your table. The other thing, so that all the 4 operations that we use or that we could find as a rule or a pattern, we're looking at addition, subtraction, multiplication, or division. And it must work, whatever we think the rule or the pattern is, it must work for every number. So it's very important that we go back and we check every number in our table. So let's look at this input-output table. If I input 5, and my output is 15, then I can think of a couple of different things. I know the last one we just did was addition. So if I had 5 and I added 10, so 5 plus 10 would equal 15. So, okay, that's the first thing I do. I usually look at the first set of paired numbers on my table, and I try to find the pattern for that. So I started with addition. I think it's going to be adding 10. So, but it has to be true for everything. So let's look at my next set of paired numbers. Let's look at the 4 and the 12 right there. Let's look at that. So 4, if I'm still following that rule or that pattern, is 4 plus 10 12? No, it isn't. So plus 10 is not my rule. So I need to go back again and look back at 5 and 15. So what other connection can I make between 5 and 15? Well, I know I can skip count by 5s, 5, 10, 15. Oh, so maybe this is 5 times 3. So maybe my rule is times 3. So let's see if that works on my table as well. So maybe it is times 3. It could be times 3. Oops, that's not working. All right, so we're going to think it's times 3. So let's go back and look at 4 and 12. So is 4 times 3 12? Yes, it is. And I know my multiplication facts. And remember last week, boys and girls, in our lesson, we talked about T-charts and T-tables and our multiplication chart. So if you didn't know, you could do a T-chart right here next to your table to test to see if times 3 was correct. So we could always do that right here, times 3. So that is a tool or a strategy we've already learned and talked about, but you can still use it for this, right? So 3 times 4 is 12. So let's look. 2 times 3, is that 6? Well, 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. So we know that 2 times 3 is 6, so that works as well, doesn't it? So that's working, this one's working, and this one is working. So the next one on our table is 7. So you notice, boys and girls, your input does not always go in order, does it? It doesn't go in counting order of your numbers. So let's check 5. 5 times 3 we know is 15. So what is 6 times 3? 6 times 3 is 18. That's 3 more than 15. And then 7 times 3 is 21. And look, 7 times 3, 21. So what is our rule for this table? Our rule this time is we are multiplying by 3. And we know it's the pattern. We proved it because we checked everything on our table. Okay, boys and girls, here is our next table. Let's look to see what this one is a little bit different this time. It doesn't say input and output, but we're still going to read our relationship table, reading from left to right like we always do. So I see a label that says number of bags. So I have 1 bag, 2 bags, 3 bags, 4 bags, and 5 bags. And for every 1 bag, I have 8. This says I have 8 shells. Number of seashells would be 8. So I notice way down here on my table, I have something missing. Well, sometimes your charts are missing and your question has to do with how many that missing is. So let's read our question. It says, Mindy placed seashells in bags. If the pattern continues, how many seashells will be in 5 bags? So the number of bags. Well, if I have 1 bag and in my input and I'm getting out 8, what am I counting by 8? What am I doing? Am I multiplying? Am I dividing? Well, 1 plus 8 is 9. So I must be multiplying. So let's see if multiplying by 8. And you know, Miss Ryan likes to do this little strategy where I kind of put my rule here and see. I use that kind of like a little mystery column. It's my math mystery column. So 1 times 8, does that equal 8? Yes. So far we think our rule is times 8. Let me check. 2 times 8. Well, what is 2 groups of 8? Is it 16? It equals 16. Check. And 3 times 8, because remember it has to follow the same rule all the way down. 8 times 3, does that equal 24? Yes, it does. This is a super great one because it's all in order, isn't it? And it started with 1, so it was really easy. 4 times 8 equals 32, and I know that again because I know my multiplication facts, but if you don't, you should be drawing your T-chart, multiplying by 8 to check all of your numbers, all of your products. So 5 times 8, I can count by 5 8 times, 5, 10, 15, 20, 25, 30, 35, 40. All right, so this was the one where we didn't know what it was. We're going to write it ourselves. All right, so what did we determine the rule is for this table? We said the rule is multiply by 8. multiply by 8. And so if that's the pattern or the rule, how many seashells would be in 5 bags? Well, we figured that out, didn't we? We said it was 40. We said it was 40. So I'm going to write right here that it would be 4. Oops, Miss Ryan, let's change that so we can see it a little bit better, darker. It would be 40 seashells. 40 seashells. All right, boys and girls, here we have another example. Sometimes we have our input-output tables where it goes across the page like this one. This was a little bit different. The other ones we looked at, we were stacking them on top of each other. And we did vertical. We had a vertical table or chart, relationship table. But this one is horizontal. It goes across. But we're still going to start. We have to think about the top to the bottom. So I'm going to read this problem, and we're going to talk about how to solve this one a little bit differently. Remember, we've done some examples. We did one with addition. We've done one with multiplication. And I already noticed that my number on top is bigger than the number below it. So I know that when I start with a bigger number, there are 2 operations I can think of. I can use subtraction and I can use division. So I know already in my mind I'm going to be thinking about using a rule that is a subtraction rule or a division rule. So let's look at our problem right here. It says John recorded the number of popsicles that were in a certain number of boxes. According to the pattern, how many popsicles are in each box? Oh, there's a second question. How many popsicles are there in 9 boxes? So this is the 2-step problem. And see, I can see number of boxes is 9 and this is blank. So I've got to fill in and finish my table. And so let's look first. Let's always look for your pattern first and test your pattern. So I know that in the 3rd grade, we mostly do multiplication and division. So I want you to start out thinking about division. Now remember, multiplication is the inverse or the opposite of division. So you can always think about that too. So I am thinking about 12 divided by something would give me 2. Well, I know that 2 6s or 2 times 6 is 12. So is it possible that my relationship is a division? Well, let's test it out. So I know that 12 divided by, so we're testing out, divided by 6 equals 2. Oops, Miss Ryan, you messed that up. Let's see, let me fix that. Okay, got that fixed. So now we have 12 divided by 6 is 2. We know that because we can think of the inverse. 2 times 6 is 12. So let's look at 18 and 3. If I divide 18 by 6, will I get 3? Yes, I will. I know that because if I think about it backwards, 3 times 6 is 18. So 18 divided by 6 is 3. And if you don't know your multiplication facts, you're going to go back and you're going to make that T-chart over here like you would. You're going to use that strategy we've already learned and practiced. So my next one, remember, it has to work all the way across. So 30 divided by 6 would be how much? 5. That's right. And I know that 5 times 6 is 30. I can count by 5 6 times. 5, 10, 15, 20, 25, 30. I know that that's right. And then I'm just counting back up. So boys and girls, Miss Ryan's really showing you some pretty easy ones because we're going sort of in order, although I skipped the number 4, didn't I, on this one? So 42 divided by 6 is 7. I know that because 7 times 6 is 42. Now look, we've gotten here and I don't know my multiplication facts, but I do know that 7 times 6 is 42. So I'm doing my 6s. I finished with 7 times 6 is 42. So what would 8 more be? So 42 plus 8? No, it's not plus 8. Remember, 8 times 6. So it's 6 more, not 8 more. So it would be 42 plus 6 more. So 6 times 8, boys and girls, is 48. 48. So don't make that mistake. And then I just have to go one more. 9. 9 times 6. Well, 9 times 6 is 6 more than 48. 48, 49, 50, 51, 52, 53, 54. Oh, that's right. Now I remember. 9 times 6 is 54. So to finish out my table, I would have a 54 here. 54 divided by 6 is 9. And I used one of my other strategies over here, didn't I? So what was the rule of this table? This rule, we were dividing by 6. So that's how I am writing my answer. And then look at the other question. Our other question said, how many popsicles are there in 9 boxes? Well, look at my table. Here's the number of popsicles, and here's the number of boxes. I had 9 boxes. So how many do I have? I have 54. So there are a total of 54 popsicles. And I should write popsicles. Miss Ryan has trouble with this pen because I have to use the little, I can't use my actual pen or a pencil. I'm having to use my mouse. Popsicles. It's different than what you're doing on the flip chart at school. This is a lot harder, boys and girls, let me tell you. All right, so that's where we're at so far. Let me double check and see if we've got one more question. Okay, boys and girls, you lucked out. Miss Ryan doesn't have any more for you. Those are your examples. So remember, you are looking to find the rule of the pattern, the rule of the relationship table, what you put in, what rule are you following to get whatever is coming out. Remember that we're using multiplication and division mostly for 3rd grade, but we did do some examples where we used adding and subtracting. So remember, adding and subtracting, for adding and for multiplying, numbers start smaller and get bigger. Your input is smaller than your output. So if it's going to be a rule where your input number is bigger or larger value than your output number, you know you're going to be using subtraction or division. So boys and girls, on your assignment that you're going to be doing with this week, you have to find the rule for every table, and you also have to answer a question. So good luck. I'll see you next time. Bye.